if we want to have this flexibility, for example, on the fabric, which temperature or which speed or which layer thickness we have to optimize, or we have to set a select parameter before we proceed and start printing. The material and the equipment that we use. Questions? Nope. Okay. The material and the equipment that we use just out of Amazon, some PLA and conductive PLA and TPU material, nothing specific. We're going to go over in details today about the material. Also, I tried last time I shared with you guys where I was trying to see what type of adhesion I have to put on the fabric in order to make this fabric stick on the build platform while we are printing. I tried a couple of ways to do it. Unfortunately, the magnet, I tried first double-sided tape. Unfortunately, it was so bad. I tried to put like clips. It was also so bad. And then we end up doing like just magnet. Magnet was so easy to clean. You just remove the magnet. You have your fabric, and strong magnet can take care of this. The equipment we have in the lab around 17 Lasbot FDM printers, so I was able to dedicate one printer only just to do this project on it. Again, yeah, here we go back to the material. The TPU material, it's we got a lot of nice results using TPA. It maintains the flexibility and structural integrity, as you guys saw last time when we got use a 3D printed fabric. The PLA, reliable bonding on cotton, because I also try different type of material. We tried cotton, we tried nylon. But the problem with the PLA, as you guys know, it's not that flexible. So the application of it, I don't know if we're going to have any application. The application, I guess, it's more like for the TPU because it is squishy material. It is flexible. And as we mentioned last time, I want to try the conductive PLA because if we have conductive PLA, we can have some wire and we can have a functional system. Unfortunately, we couldn't do it to have a good adhesive so far for the conductive PLA. I wish it was great as a TPU, but it's not something that we can use for the future research as of right now. For sure, hopefully in August or in the fall, I'm going to continue working. I really care about the conductive PLA because it's going to be the future. Here we got some parameter and some standards that I would like to have maybe like a publication later this summer or this fall, just to share this information with everybody outside. If you guys want to print using PLA, what parameter you should have, what temperature you should have, the fan speed. I don't want to go into a lot of details. I know we have only 10 to 15 minutes to present. Starting nozzle temperature around 205 Celsius. Optimization method, we're just trying to increase 5 degree every time, because using this Lasbot, you can do it, which is good about the Lasbot. I mean, you can change this temperature. We start having minor deformation observed when we got the temperature above 220 with improved adhesion. So again, everything is like take and give. So you can't have a perfect adhesive with no deformation. We're gonna also work on this, continue working on this. TPU, this is the example that we got you guys in person last time. Starting nozzle temperature 225, again increasing 5 until we reach 235. Minor deformation happened at 235. Also, we got a slight improvement in adhesive at a higher temperature. So you can see here we have almost 10 degree difference room to play between the PLA and the TPU. Conductive PLA, the optimal nozzle temperature was around 250. Higher temperature improved adhesion, as you guys saw in all these 3 examples before. But again, I couldn't really feel like, yeah, the conductive PLA, it can be for future, it can be something that it can be applicable as of right now. Also, I tried using textile for the nylon. Starting bed temperature. Also, the good thing about these last bot is that you can also change the temperature nozzle, the temperature of this bed. So if you guys see here, the main trick is the temperature. You don't want to make it so hot, you don't want to make it so cold. You want to just keep changing until you find the best temperature. 75 degrees Celsius produce stronger adhesion, but increased polymer relaxation. I wish I can increase it to 80, but the problem is we're gonna start to have deformation with the material. Maybe later I'm gonna see if we can find like a polymer or a material that it can accept a little bit more temperature. Nylon demonstrated an excellent compatibility with polymer deposition. I couldn't get you the sample, unfortunately. I have it in my office. The last sample I showed you guys last time, a couple of weeks back, it was using cotton, 100% cotton. But we got also some nice result on nylon. Here we go, 100% cotton, starting bed temperature at 60, optimal gonna be 75. We have wearable adhesion. Also, I tried on the cotton to see, to print a layer and of material in the back of the fabric and then flip it and put it back and start printing. I thought like having this piece of cotton between two layer of TPU or two layer of material, it's gonna help me, but unfortunately it never helped. So there is no need to do it like this again. Just put a piece of fabric, put a couple of magnets on the four corner and start printing, and you should be ready to go. Here we got you. I added this picture here. I know I couldn't. This is what I showed you guys last time. The fabric on 100% fabric, TPU material on 100% fabric. And these were the primary variables that we were working on, as we mentioned before in these couple of slides: nozzle temperature, the bed temperature, the flow rate, and the print speed. I was able to get some nice result for the nozzle and the bed temperature. As you guys saw before, I was always able to optimize the process. I'm gonna still be working on the print speed, but unfortunately, I couldn't find a way yet to change the print speed on this last printer. Hopefully in August or during the fall. It just needs some more time. That's it. Some key experimental findings: the magnet provided the highest print quality and consistency. Clips were no good. Double-sided tape was an awful way to do it. Cotton showed a great bonding with PLA. Also, nylon demonstrated a stronger adhesive with and polymer fusion. But the problem was I didn't really like to use the nylon a lot, because if you want to do the application, people don't like fabrics that it is 100% nylon. Even if you want to put it on your in your skin, people don't like it. This is why I am planning to stick with cotton, 100% cotton, because we are doing something that it should be used later. Here's some result. We already shared all these results in this today presentation, but these results support the future application in wearable devices, soft robotics, smart textiles, aerospace also, and customized manufacturing. We just have to now, actually, maybe it's a good time to go and visit local companies or local clinic, and just to see if we can sell this product, just not like to sell it, just to see if it's something they can use, or they are willing to adapt, or maybe they can give us some information, what stuff we have to update, what stuff we have to change, because it's still in a lab. It's not something like nobody know about it. So hopefully in the next few weeks, we're gonna reach out to the right people to see if it's something really usable for them, or it was just a good experiment in the lab. Key domain application: wearable protection, soft robotics, aerospace, smart textile, customized manufacturing, and fashion also. It can be one of the application. And I hope it was short and sweet. If you guys have any question, please feel free to ask.